Look at both of these. So when I have this first one, I am going to rewrite it so that I can see, actually I'll just do this. The 8x to the 4th y cubed divided by the 14x cubed y to the 5th. All right. So the first thing I'm going to look at is the numbers. Is there something that goes into 8 and into 14? Yeah, so 2 goes into both of those. So I am going to end up with 2, and I'm going to end up with 7. Not 2. No, not 2. 4 and 7. All right. So now that I have that, what about my x's? Can they reduce? So how do I reduce my variables? X to the 4th over x cubed. How do I reduce those? Remember from reducing when we had exponents, properties of exponents? Yeah, you subtract, right? That's when when you're dividing, you subtract, right? When you're multiplying, you add. When you're dividing, you subtract. So you have 4 in the top and you have 3 in the bottom. So we can take 3 out of both of them, right? We can take 3 out of both of them. So we're just going to have 1 left on top and we're not going to have any left on bottom. All right? Everybody see? 1 left on top, none left on bottom. What about my y's? I have 2 left. Where? On the bottom. So I have 2 y's left on the bottom. All right. Now I have reduced the fraction itself as much as I can possibly reduce it at this point. Okay. As much as I can possibly reduce it. Now I'm going to look and see if I can reduce the individual radicals themselves. All right. So I'm going to look at the top, 4x. Can anything simplify out of the 4x? Yes. 4 has a perfect root, doesn't it? What's the square root of 4? 2. So I can actually take this out as a 2. The square root of 4 is 2. The x cannot come out because it's alone. If I had 2 x's up there, what could I have done? I could have pulled an x out, right? Because it would have paired up. But I can't take an x out. It's going to stay in. On the bottom, my 7. 7 does not have a perfect root, right? So it's going to stay inside the root. But what about my y's? I have 2 of them, right? So if I were to do my little factor, you would see they group up. So a y is actually going to come out of my root. All right. Now remember yesterday we talked about when you're simplifying, it is not in simplest form if you have a radical left in the denominator. And if you have a radical left in the denominator, the way you simplify it is you multiply the top and bottom by that radical. All right. So I'm going to take this and I'm going to multiply the bottom by the square root of 7. And I'm going to multiply the top by the square root of 7. All right. Now on the top, remember when I'm multiplying, I multiply the outsides to each other and I multiply the insides to each other. So this 2 is on the outside. There's nothing for it to multiply with because there's nothing else on the outside. So the 2 is going to stay on the outside. On the inside, I have x and 7. When I multiply those, they just become 7x, right? So I just have this guy right here, 7x. On the bottom, when I multiply a square root by itself, what happens? The root just goes away, right? So this square root of 7 times square root of 7 just becomes a 7 without the root. So I have 7 times y, which gives me that 7y. And this is my answer here. 2 square root of 7x over 7y. All right, so let's look at the next one, 24. Once again, you want to write it over so you can easily see what reduces. 5xy over 10x squared y cubed. All right. Now there's a couple ways to do this one, and we could have done the other one this way as well. But when you're reducing, you can either take it out ahead of time or you can reduce first. So whichever is easier. I tend to think if you do the same pattern, you do it. So in this case, you could take that x out on the bottom first and a y out if you wanted to, or you can reduce them first and then worry about simplifying. So let's look at the numbers first. How do the numbers reduce? 5 over 10, how is that going to reduce? It's going to be what? 1 over 2, right? What about my x's? Yeah, I just have 1x on the bottom, right? So 1x on the bottom. What about my y's? 2y's on the bottom, right? 2y's on the bottom. So far, so good. Now can I simplify my radicals? Square root of 1, does that have a perfect root? Yes, it does. The square root of 1 is just 1. What about the square root of 2? No. What about just the x? Also no. What about the y squared? Yes, it pairs up, right? We have 2 y's there, so 1 y can come out. We good? What's my last step here? Yes, we need to multiply by this radical, right? We need to do this right here. I just have 1 times the square root of 2x on the top. That's going to give me the square root of 2x. On the bottom, this whole thing becomes just whatever it is without the radicals. So this becomes 2x. So I have 2x times y. That's going to give me 2xy. Now, can I reduce the 2 and the 2? Yes or no? No. Why can't I? One is on the inside, one is on the outside. Same thing with the x's. The reason I'm saying this is a common mistake here. People get to this point and they think they can reduce. Inside to outside cannot reduce. Okay? So we are finished. This is my answer. All right, so for number 12, you're just going to write it as a fraction like we did on bell work, square root of 3 over the square root of 2. You're going to look and see, can I reduce those? You cannot. 3 and 2 do not reduce. So the only thing I have to worry about is getting that radical out of my denominator. And so once I do that, I'm going to multiply my insides, 3 and 2. That's going to give me the square root of 6. This becomes just the 2 without the radical. And you cannot reduce inside to outside, so you are done. All right. So look at the next one, 114 over 32. When you have something this big and you don't know what goes into both of them, you can start with something small. Obviously, they're both even, right? So 2 is going to go into both of them. So you can start by just reducing by 2 and see if that is good. And so if we reduce these by 2 into 11, that's going to give us 5, right? With 1 left over, 2 into 14 is going to give us 7. 32 divided by 2, what does that give us? 16. All right. Now at this point, you want to see, can I reduce those any further? All right. Can I reduce those any further? Neither one of those are prime, but you don't end up with numbers that are the same. So they won't reduce anymore actually between themselves. So now I'm going to look at them individually. 57 does not have a perfect root, nor does it have anything that will come out of it. I think it's 3 and 19, right? 16, however, has a perfect root. What's the root of 16? 4. So I'm going to say the square root of 57 over 4. I'm done at this point. I don't have a radical in my denominator, and my 57 is as simple as it gets inside the radical. So this is my answer here. Adding and subtracting radicals. When adding or subtracting terms that contain radicals, you have to be sure that they are like radicals. Think of it like we did when we did variables. In order for it to be the like variable, they had to be the same. You can add 2x and 3x because the x is the same. And you do that by just adding the coefficients, 2 and 3, which gives you 5 x's. Radicals are the same thing. 2 square root of 5 and 3 square root of 5. Your radicals both have a 5 in them, all right, which means they are like radicals. So you just add the coefficients and you get 5 square root of 5. And so if you look, they actually have the little definition there. Like radicals are radicals that have the same radicand. Radicand's the number on the inside, and the same index. Just like with variables, you have to have the same exponent. With radicals, you have to have the same index. So these both had a 2, square root of 2. Their index was 2. If they have the same index and the same radicand, you can add them. You can add them. So look at the rules. Simplify each radical. So the first thing you want to check is make sure that your radical is in simplest form. All right? Meaning you cannot do the factor tree and pull something else out of the radical. If they are then alike, you can combine those coefficients, the numbers in front of them. So the first one's very simple. They are alike. We have the index of 2, right? These are both square roots, and my radicands are both 3's. So I have 4 square root of 3 plus 2 square root of 3. I am simply going to add those coefficients, 4 plus 2, which gives me 6, and my square root of 3 does not change. Inside does not change. So when you are adding like radicals, the only thing that changes is the coefficient, which is the same as when you're adding variables. 6 square root of 3. Okay? Really simple. All right? So the reason the first step is to make sure your radical is simplified is because you may have like radicals, they're just not in simplest form, so you cannot see it yet. So you can see, if I look at these, I have a square root of 45 plus a square root of 18 minus a square root of 5. Right now, none of them look alike, but 2 of them are not in simplest form. All right? So I'm going to take these and I'm going to simplify them. I'm going to say, well, 5 goes into 45. And that is my prime factorization there. I'm going to take out the 3's. I'm going to leave the 5 in. So that one becomes 3 square root of 5. Make sure you bring down this plus before your next step. Then I'm going to do the 18, 2, and 9, 3, and 3. And I have a 3 that comes out, and I have a 2 that stays in. And then make sure, once again, you bring down this minus sign. My square root of 5 is already in simplest form, so I'm just going to write the square root of 5. And remember, if you do not see a number in front of it, it is a 1. All right? Now when I look at this, I have 2 terms that I can add, right? I have 2 that are alike, the 3 square root of 5 and the negative 1 square root of 5. And that's what I'm going to combine. I'm going to say 3 square root of 5 minus 1 square root of 5. Those are the ones I'm combining. 3 square root of 5 minus 1 square root of 5. What's my coefficient going to be in front of the square root of 5? 3 minus 1. All right, so 2 square root of 5. This cannot combine with anything. The 3 square root of 2 does not have a like radical, so we're just going to say plus 3 square root of 2. This is as simple as this gets. I cannot combine those. They are not alike. So I am finished with this particular problem. My answer is 2 square root of 5 plus 3 square root of 2. You can do this with a higher index. You just have to make sure when you simplify that you simplify based on the index that you are using. So in this case, we have these 3. Right now, none of them are alike. And so we are going to simplify. This first one is already simplified. We have a -8 on the outside. We have the cubed root of 5 on the inside. For this 40, we are going to use our factor tree. All right. And so for this one, we have groups of 3 is what we're looking for. So those 2's group up and they're going to go on the outside. We already have a 9. So we have a 9 times that 2. And then what's left is a 5. So we have the cubed root of 5 there. Don't forget the minus. On this last group, we also have something on the outside. And then we are going to factor tree again. Right? So we have this. And then once again, we're looking for groups of 3. So that's times the 3. The 5 is left on the inside, cubed root of 5. All right. And so we now have like factors. We do need to simplify the outsides. So we have this stays the same, -8 cubed root of 5. Then we have 9 times 2. So that's going to give us 18 cubed root. And I keep writing a 5 there, of 5. And then we have 2 times 3, so -6 cubed root of 5. And so now you can see where they're all like. My indexes are all 3's. My radicands are all 5's. And so I'm just going to add these up. I'm going to say -8 plus 18 minus 6. That's going to give me 4. 4 cubed root of 5. All right. So always simplify first, even if it is a higher exponent. When you're combining them and they have variables, you have to think of 2 things. One, is my radicand alike? So is my radical piece of it alike? But then when you're adding the coefficients, you also have to have like terms. So even if these were like radicals, right now I can't add the 2x and the 5 because I have an x in one and I don't have an x in the other. So when you have variables, you have to consider both of those like terms. Are my coefficients like so that I can add those? Are my radicals like so that I can add? All right. And so right now, obviously, neither is true, but I am going to simplify. So I'm going to simplify this one first. All right. It is just an index of 2. So this 5 is going to come out. I already have a 2x out here. So I have 2x times the 5. I have a 2 that is going to stay in. And this x is actually also going to stay in because it is all alone there. Don't forget your minus. My 5 is already on the outside. And then I am going to simplify this one. For this one, my 2 pairs up. So I'm going to say times 2. And I have a 2 on the inside as well. Then I'm going to look at my variable. For this variable, it is x to the 3rd. I divide that 3 by my index. What is my index again? What's the index of this radical? 2. 3 divided by 2 is 1 with a remainder of 1. What does that tell me? This tells me what's going to go out, right? How many x's are going to go out. This tells me how many x's are going to stay in. So I have 1 x that comes out, 1 x that stays in, right? Then I'm going to simplify those coefficients. 2x times 5 gives me what? 10x. And on the inside, I still have a 2x. Minus 5 times 2x. 10x. Actually, this is an x as well. And on the inside, I have 2x. So I'm going to subtract my coefficients. 10x minus 10x. What is 10x minus 10x? 0. I have 0 times the square root of 2x. What is that? 0. That's my answer. So I'm going to take them individually. This first one, the 2. Can the 2 simplify at all in a radical? No. 2 is already prime. All right, so my 2 isn't going to stay on the inside. What about this x squared? Yes. What's going to happen to the x squared? It's x and x. It pairs up. All of my x's come out, right? Let's look at the next one. 75. That's 3 and 25. 5 and 5, right? What's going to come out? A 5 is going to come out, right? What's going to stay in? 3, right? I can actually do this in a different color. So a 5 is going to come out. A 3 is going to stay in. What about my variables? X to the 4th divided by 2. That's 2, remainder of 0, right? So how many x's are going to come out? 2 x's are going to come out. How many x's are going to stay in? No x's are going to stay in, all right? Don't forget your minus sign, by the way. Minus. I already have a 2x squared out here. 2x squared is already out here, all right? Can I simplify my square root of 3? No, it is as simple as it gets. So that one is done. For the next one, what do I already have out here? Minus x, right? Then we can simplify this 18. How do I simplify it? 2 and 9 and 3 and 3. What comes out? 3. What stays in? A 2. All right. Now I need to simplify these. This guy right here is as simple as it gets, right? X squared root of 2. Do you see any like terms? Yeah, this right here is a like term, isn't it? It has an x on the outside. That's a like term on the outside. It's a 2 on the inside. It's a like radical. So negative x times 3 is negative 3x. And I have my like radical of the square root of 2. Everybody see that? All right, look at the next group. 5x squared. And minus 2x squared, right? They both have like terms on the outside. They have like radicals on the inside, right? You don't necessarily have to group them this way. You can just add them as you go, but I'm just showing you. Once you have them paired up, you just subtract. X minus 3x is what? What's x minus 3x? 1x minus 3x is negative 2x, and my radical does not change, right? I have 5x squared minus 2x squared. What's 5x squared minus 2x squared? A positive 3x squared, and my radical does not change. These cannot be combined for 2 reasons. First of all, my coefficients are not like terms, even if my radicals were. My radicals are not alike. So even if the radicals had been alike, this is as small as I can get this, really. I could potentially factor out the radical and show it on the inside, but that doesn't make it any more simple. So this is my answer. Negative 2x squared root of 2 plus 3x squared square root of 3.